Linear searches are clear, they're understandable, they're easy to write, and they're slow. But if the values in your array are in ascending or descending order, you can do a binary search instead. It's much faster, and here's how this works. Imagine we have an array of integer values. Now, this could be strings, could be anything, as long as the values are ordered. And I want to know if the value 99 appears somewhere in this array. Again, with a linear search, I would begin at the first element and I would check every single value. But a binary search is different. It begins not by looking at the initial element, but by getting the length of the array. In this case, it's 22 values. It divides the array in two, and it immediately jumps right to that point, right to the middle of the array, and compares the value at that position with the one we're looking for. In our case, what we're looking for is 99, and what we've just found at this midpoint is less than that. And what that means, because these things are in order, is I can now completely discard this element of the array and all the elements below it. So in one move, we have just discarded half of the array. We know these values are in sequence, so the value we're after cannot be in the lower half of the array. We don't need to look any further into it. So we then move on. We take the remaining half of the array and we divide it in half again, jumping directly to its midpoint. We check that against the result we're looking for. Well, this time, 108 is higher than 99, so our result is not this one or anything above it. We can now ignore the upper section of this. And then we move on, continuing to divide in half every time. We check the result, we discard the irrelevant half, we move on till we either get a match or we realize there is no match to be found. And this is a binary search. And here the word binary is nothing to do with the zeros and ones of binary computer code. It's binary simply meaning in two pieces. We are dividing the array into two pieces every time. This is also referred to as a half-interval search, or more generally, a divide and conquer algorithm. And this is an incredibly efficient way compared to linear searching, particularly as your arrays get larger. You can work through arrays of hundreds or even thousands of elements with only a handful of checks. Well, sounds great. So a common question, how can I do a binary search if my array is not ordered? Well, the simple answer, you can't. End of story. Binary searches can only be done on ordered data. That is their inherent constraint. Now, you will find binary search functionality already exists in almost every language. For example, Java offers binary search methods in their array utilities. .NET languages have binary search methods on the array classes. C++ has binary_search in the standard template library. Unfortunately, JavaScript doesn't have any kind of built-in binary search abilities. We've got bsearch in Ruby. And while Objective-C doesn't have a method with the name binary search, it does support this. There is a version of the indexOf method, again, indexOf used to find something, but we're using this option that it's using sorted data. It's got a sorted range of data, in which case it will do a binary search and not a linear search. Now, as you might imagine, if you feed an array that isn't actually sorted into any of this, expect some kind of error or null result. Now, this is the important thing to take away here. As a pragmatic, practical software developer, you don't want to write binary search algorithms. Okay, they're conceptually simple, but don't underestimate them. The devil is in the details. But seeing as this functionality almost certainly exists in whatever language you have, you should be able to recognize when to use it. You're thinking, hey, I've got some sorted data and I need to search it. I might have just written a standard indexOf statement, and yes, that will work, but let me look at the documentation and make sure that isn't going to do an inefficient linear search through all the data when I could do a much faster binary search instead. Again, it's a performance saving that is there for the taking. Now, although binary search is great for sorted arrays, we will see it again as we go forward because it's not just for arrays. And next, we're actually going to move away from arrays and finally start exploring additional data structures and see how they solve some of the problems that arrays have already presented us.